Hello, Professor Sargent here with you again. We're going to take a look at some problems regarding compositions of functions. The composition of a function is where you put x into one function, you get an output, turn around and call that x being plugged into a function that follows it. If we want p of g of -2, p is this portion of a parabola down here, and g the portion of a line, well, x is first going to go into g. When x is -2, g is equal to -1. Follow that by p. When x is -1, plugged into p, we get -12. And we can see over here, p of g of -2 is -12. And the order matters. If we put -2 into g first, into p first, when x is -2, p is -9. You plug that -9 in for x in g, you get -15. So g of p of -2, or g follows p at -2, we have a different answer, -15, than from the reversed order. Now, real quick here also, if I were to put in, say, 0 into g, it's telling me put in x equals 3 into p. But 3 is not in the domain of this parabola. Well, maybe I went far enough. Okay, -4. So, all right, let's put in 1 into g. And that gives us -4. Let me think a minute. Okay, here's something that'll definitely be a problem. Either function does not go as far as x equals 5. 5 is outside of the domain. So if I were to try to find g of p of 5, it's giving me a question mark because it wasn't even in the domain of p. However, if I were to put in 0 into p, it gives me -13. -13 is not in the domain of g. So if I try to find g of p of 0, it's going to give me that question mark. Since the output of p at x equals 0 is not in the domain of g, then 0 is not in the domain of the composite function g follows p. And back with the previous one, if it's not in the domain of the inner function, then it's not going to be in the domain of the composed function.